Hello everybody, my name is Ethan. Welcome back to another video where today we are hopping back in to the machine learning course on Codecademy. A couple things before I start the video. Sorry, it's been a couple of days since I have been on and active on this channel. I just want to say I'm sorry about that. I had some things come up, so I'm going to try and get back into it and get onto the daily uploads like I've been doing. In the previous video, we did a little bit of an introduction into the software engineering. We didn't do exceptions, but we did do concurrent programming, so that was the last one that we ended up doing. We're close to 70% of the way through the course. I know it shows that I only have a check mark in the top two, and we're kind of, it looks like, 3/4 of the way through this third chapter. But if we go back to, the My Home section, it tells me that we're about 70% through the course, which is pretty awesome. Again, I haven't made, today is Monday, so I guess the target kind of tells you all the stuff that I'm in. But basically, we're going to continue our machine learning and AI engineer course. And we're going to be doing bash scripting today. So let's just hop right into it. I always like when we immediately get into stuff where I can, I can type, I can enter commands into the console. Sometimes just starting with the just the articles is kind of annoying, in my opinion. I like getting into stuff right away. So bash or shell scripting is a great way to automate repetitive tasks and can save you a lot of time as a developer. Bash scripts execute within a bash shell interpreter terminal. Any command you run in your terminal can be run in a bash script. When you have a command or set of commands that you will be using frequently, consider writing a bash script to perform it. There are some conventions to follow and to ensure your computer is able to find and execute your bash scripts. The beginning of your script file should start with a hashtag !bin/bash on its own line. This tells the computer which type of interpreter you'd like to use for the script. When saving the script file, it's good practice to commonly use the scripts in the bin directory. The script files also need to have the execute permission and allow them to be run. To add this permission with the file name, use script.sh, use chmod plus x script.sh. Your terminal runs on a file every time it's opened to load its configuration. On Linux-style shells, this is that. On OS X, this is that. To ensure that the scripts bin are available, you must add the directory to your path within the configuration line. In the code editor at the top of script.sh, add a line to specify that the script should be run using bash. So I'm going to assume that it's going to be this line here where we do hashtag ! Slash. It's been a minute, so the typing is going to be a little bit slower. I did that wrong. /bin/bash. Add an echo back bash command to script to print hello Codecademy when the script is run. Bash command to script. So yeah, it's just going to be echo. Yeah. I got to get back into the swing of things, guys, so it might take me a little bit to do it. Again, it's been a couple of days. In the provided terminal, use the command /script.sh, and it runs the command. Cool. All right, variables within bash scripts, or the terminal for that matter. Variables are declared by setting the variable name equal to another value. For example, to set the variable greeting equal to hello, you would use the following syntax. Greeting equals hello. Note there is no spaces between the variable name and the equal sign or hello. To access the value of a variable, we'll use the variable name prepended with a $sign. In the previous example, if we want to print the variable value to the screen, we can use the following syntax. Create a variable called phrase on the line below or before the current echo statement. So we want to say phrase is equal to the string hello to you. And then update the echo statement to make use of the variable instead of using the fixed string. So we can instead do the $phrase as it says, and then run the script. We can do that by doing /script.sh, and we see that it prints out the hello to you. All right, conditionals. When bash scripting, you can use conditionals to control which set of commands within the script run. Use if to start the conditional, followed by the condition in square brackets. Make sure to leave a space between a bracket and the conditional statement. Then begins the code that will run if the condition is met. Then else begins the code that will run if the condition is not met. Lastly, conditions close with the bracket with backwards if fi. Interesting. Very interesting syntax. A complete conditional in bash script uses the following syntax. Bash scripts use a specific list of operators for comparison. Here we used -lt, which is less than, right? So the -lt is less than. The result of the condition is that if index is less than 5, it will print to the screen. If it is 5 or greater, 5 will be printed to the screen, right? So here's a list of the different ones. We have equal, not equal, less than or equal to, less than, greater than or equal to, greater than, and is null. When comparing strings, it's best practice to put the variable in quotes. This prevents errors if the variable is null or contains spaces. The common operators for comparing strings are double equal sign and not equals, right? We've seen this before. For example, to compare the variables foo and bar containing the same string, we would do quotation foo is equal to bar. All right. We've added two different greetings and a variable to store how many times the user has greeted before. If this variable is less than 1, we want to use the first greeting. Otherwise, we want to use the later greeting. So we want to do if, and then we'll set up this if by saying if, we'll say the variable of greeting occasion, and then we would do minus is greater than, if this variable is less than, so less than 1, then I'm trying to do this all in the same area, so then we indent it in, and we want to echo the first greeting, else echo later greeting. Minus LT. Wants spaces in between. Maybe that does it. Nope. Let's read it again. If this variable is less than 1, we want to use the... So let's check this one. Less than 5. So maybe we can drop the quotation marks and see what happens. Yep, that worked, even though it said to put it in quotation marks. When comparing strings, I see. So I messed that up. We're not comparing strings. We're comparing, that's an integer value, greeting occasion, obviously, that one. Use echo to print first greeting if the conditional is met, and later greeting otherwise. Be sure, oh, I think I did that already. That's what I'm forgetting, the FI. Run the script in the terminal. Try adjusting the value of greeting occasion to test your if statement. So we can do this by doing // ripped.sh. How are you? That's the first greeting, right? Or it's actually a later greeting. So if we put 0, we save it, we do /script.sh. It's going to say nice to meet you instead. Okay, loops. There are 3 different ways to store a loop within a bash script: for, while, and until. A for loop is used to iterate through a list and execute an action at each step. For example, if we had a list of words stored in a variable paragraph, we could use the following syntax to print each one. For word in paragraph, do, echo word, done. Note that word is being defined at the top of the for loop, so there is no $sign prepended. Remember that we prepend the $sign when assessing the value of the variable. So when accessing the variable within a do block, we use the $sign word as usual. Within bash scripting, until and while are very similar. While loop keeps looping while the provided condition is true, whereas until loops until the condition is true. So kind of opposites. Conditions are established the same way as they are within the if block. Between square brackets, if we want to print the index variable as long as it is less than 5, we would do the following while loop. Right? So while the index is less than 5, do echo and then index. We're going to change the index variable by adding 1, right? And then done. Note that arithmetic and bash scripting uses the $sign parenthesis syntax and within the bracket, the variable name is not prepended with a $sign. The loop could also be written as an until loop as follows, right? So until it's equal to 5, right? Start by opening a while loop directly after the greeting occasion variable. So it wants us to do one, below this, so I'll say while, and again we do these square brackets. Want to loop while greeting occasion. Okay, so while $greeting underscore occasion is less than, and we have 3. Okay, we did it. It now says move the existing if block inside of the while loop. We can do this by just tabbing over all of these once. Now they're all inside the while loop. Remember to use the do, and then done. Increment greeting occasion on each one. So after this, we'll also increment it by saying greeting occasion equals $sign greeting occasion plus 1. I think that's just about right. Let's run it and see what happens. Move the existing fee block inside the while loop. Done. Remember to use the do and done keywords. Got it. Increment greeting occasion on each loop. So at the end of the loop here, first it runs this if, and then it increments it by saying greeting occasion is equal to, is that what I did? I think so, all right. Let's see what their solution is here. It's silly that it doesn't get caught on number 1, but it gets caught on number 2. All right, run the script. You should see the first greeting, nice to meet you, followed by how are you greetings. So you can do, we'll run the script twice. Yep. Inputs. To make bash scripts more useful, we need to be able to access data external to the bash script file itself. The first way to do this is by prompting the user for input. For this, we need the read syntax to ask the user for input and save it to the number variable. We would use the following code: echo, guess a number, read number, you guess number. Another way to access external data is to have the user add input arguments when they run your code or script. These arguments are entered as the script name, and after the script name, these arguments are entered after the script name and are separated by spaces. For example, say colors, red, green, blue. Within the script, these are accessed by using $1, $2, etc., where $1 is the first argument, and so on. If your script needs to accept an indefinite number of input arguments, you can iterate them over $@ syntax. For our say colors example, we'd print each color using for color in $@ do echo color. Lastly, we can access external files in our script. You can assign a set of files to a variable name using standard bash pattern matching using regular expressions. For example, to get all the files in a directory, you can use the $ or the star character. Right? That's something that we've definitely seen before. You can then iterate through each file and do something here. Let's just print out the full path and file name for file in $files, do echo file. Done. Let's just ask the user how many times the program should greet them before the while loop. Print to the terminal how many times. Yeah. So before the while loop, we'll say get user input. Okay. So we can now run the script by doing ./script.sh. How many times should I greet? We'll say 4. Now it's going to print out 4 times. Very cool. Aliases. You can set up aliases for your bash scripts using your .bash rc or .bash profile. We actually also saw a little bit of the .bash profile. If you missed that, another video on that on this channel. But we did set up the bash profile, which is pretty interesting. We, for example, if we have our say color script, we can alias it using the word say colors using the following syntax. Alias say colors is equal to .saycolors.sh. You can even add standard input arguments for your aliases. For example, if we always want green to be included as the first input to say colors, we could modify our alias to be saycolors.sh with green. All right, our script is updated to take argument for the number of times the user wants to be greeted. Let's create an alias so that when you type greet 3 in the terminal, it greets you 3 times. In your own environment, you could add this alias to your bash rc to make the alias active every time the terminal started. Let's just make the alias in the command line. Okay, so our script is updated to take an argument for the number of times the user wanted to be greeted. So it just wants me to create an alias. Bash within your bash. So I would assume we do it within here, but maybe not. Maybe I don't know if it's in this. Yep, it is in the command line. Now test out your new alias. Okay, there we go. Perfect. A little confusing there, but that's okay. All right, review. We looked about Any command that can be run in the terminal can be run in a bash script. Variables, conditionals, 3 types of loops, for, while, and until. All these different things. Input arguments. Inputs can be requested from the user using the read keyword. Okay, I think we're ready to go on. This is interesting. This is a new thing. This is obviously new as of literally today. But we learned 20 XP for bash, 20 XP for IT, and another 20 XP for our computer science. So very cool. That's definitely something that's new. What component makes up a conditional in bash scripting? If, then, else, and fee. Yeah. What components make up a while loop? So we have while, do, and done. What syntax is used for greater than in bash scripting? It's going to be -dt. What are the 3 types of loops? For, while, and until. What keyword is used to gather input for the user of a bash script? Read line. What command would create an alias, the answer to the script? So we would say alias, the answer equals this one right here. Fill in the character to print the word hello world. $sign phrase. Very cool. See, now it's going to tell us that we get XP after everything we complete, which is, I don't know how I feel about that, but it's something. All right, we got an objective here. Looks like only 13 tasks, which is obviously not that much. So let's take a look at the build and source files. If we go open navigation, we can see build. There's nothing in build. In source, though, there's some other stuff with some HTML files and stuff. Okay. Get started in the script by adding the header, which is the $!bin/bash. Welcome the user. Feel free to use your own style here. So we can just echo welcome to the jungle. PMX jungle user. So we'll save it, and then we can do /script.sh, and it says welcome to the jungle DMX user. Cool. So since we're creating a new build, let's verify that the user has updated their change.md log with the current version. The first line of the file contains the version number with markdown formatting. So read the first line of the file into the variable first line. You can use Linux command head for this purposes. Don't know that one. Oh my goodness. So head, just the file name. So we're going to say this variable is first line equals to the command head of what? Command not found. Yeah. They didn't show us anything like this. There's literally absolutely nothing like this in the course, of course. So we'll just try and kind of go along with what we know. So we can do head n1 source/change log.md. Let's run it one more time and see what happens. /script. It did not read it in. Oh, I guess it just saved it. We want the version number without the markdown formatting. The command read can be used to split a string. Okay, so now it wants us to split this string by using read minus a. We want the array split first line from the variable first line. We're now ready to set the value of the version of the script. It's located at index 1 of the first array. The syntax for accessing the value of an index out of an array foo is, so we'll say version is equal to, and we can do the $ formatting where we are going to do, I guess we'll just do this where we say split first line at the index of, and it tells us it's at the index of 1. Let's hope that works. Print a statement to the terminal notifying the user the version. Okay, so what we can do here is say echo you are on version, and I don't know if string interpolation is a thing, so I'm just going to create a new echo statement where I'm just going to echo the version variable. That way, because they didn't teach us string interpolation for bash scripting, which is fine. Okay, cool. So you are on version 11.2.3. Everything seems to be looking good right now. So I think we're good with the first 5 here. All right, let's give the user a chance to exit the script. If they need to make a change to the version, ask the user to enter 1 for yes to continue and 0 for no to exit. Assign their variable to a variable version continue. So now we'll say, first I'm going to echo just a line kind of separating everything, right? That way we're going to say, now we're going to ask the question, enter 1 for yes to continue, or enter 0 for no to exit. And we'll add another echo line where we say you okay, so then we'll say read, we'll put a read line, and then we'll say version continue. Okay, that's that. Add a conditional if the user said 1, so now we can do this. So we'll create a new if statement in the bracket notation, right? And we'll say if $version continue is equal to the value of 1, we're going to say then. So for now, respond okay. So we'll just say echo okay. Else, please come back when you are ready. So now we can do this again here. I'm going to just click clear, get it out, and have it nice and easy here. If we do /script.sh, we could say, welcome to the DMX jungle. You are on version 11.2.3. Do you need to exit the script or change the version? Enter 1 for yes to continue, or enter 0 for no to exit. If we click 1, it's gonna, line 18. Oh, we need to exit it with the fi. So a little bit of a mistake there. Obviously, we need that conditional fi to end the if statement. So now we can do slash script.sh. We can enter a 1 again, and it's going to just tell us the OK, which is perfect. That's all we want right now. But I am also going to test the the other one that happens, just so we are fully aware. Do you need to exit the script or change the version? We're going to say so I'm going to rephrase this question. Oh, so it just says, please come back when you are ready. Oh, because I didn't put in echo. But I am going to change this question, and I'm going to say, do you wish to stay in the script? Just because we're saying yes or no, right? So do you wish to stay in the script? Enter 1 for yes, or 2 to continue, or enter 0 for no to exit, right? That way, the question's a little bit more clear. In the previous one, if you just look over here, it says, do you need to exit? Enter 1 for yes to continue, or 0 for no to exit. So a little confusing, obviously. Now we want to copy every file from source to build except for secretinfo.md. Within the positive conditional where the user said OK, start by iterating over all the files in the source directory and printing their names to the terminal. Oh boy. So instead of this echo OK, we're going to say we want to copy every file. And yeah, that's what we use. OK. So instead of this echo OK, we're going to say for file name in source directory, right? That's what it wants. We want it to do echo copy, just printing their names to the terminal. So we're just printing file name. So that's good for right now. I'm going to clear this again and do ./script.sh. We can click 1, and right now it does what exactly we want to. But if you noticed, it says except for secretinfo.md, but we obviously have secretinfo.md. So the first thing we're going to do is, instead of just having it say echo the file name, we're going to do another if statement where we say if, we'll say $file name is equal, and because it is a string, I'm going to, put it equal to that. We'll say equal to, and we want source/secretinfo.md. If it is, inform the user that it's not being copied. So we're saying if this is the case, we're going to say then echo, we're going to say this item is if it is, inform the user that is not being copied. Not being copied. Here's what we'll do. We'll do $$ file name is not being copied. Else echo $ file name is being copied. Okay, let's see if this works. /script scripts.sh. Click 1. Oh, sorry about that. We do obviously have to do the FI first before we do the done. Always forget that. So we can try again. And perfect. It's exactly what we want to see. Now we can actually copy the files. After informing the user that the copy is being filed, copy the file into the build directory. You can use the terminal to make sure the right files have been copied. How will we do this? CP. CP $. Okay. The final thing that we want to do is list the files in the build directory for the user outside of the loop. Outside of the loop over the file names in the directory, use the script to change the directory to the build directory so that we don't forget. Also add the command to change back to the directory with the script. Outside of the loop of the file names, use the script to change the directory to the build directory. Yeah. I see. This is basically, I guess this is a little bit obvious, but this we're just executing, even though it's just in a code here, we're executing this inside of a bash terminal. I'm kind of understanding, and my phone is absolutely blowing up. CD build, we'll add more code here later. Okay. To notify the user when we're in it, so we can say echo, we are in the build directory. Okay. Interesting project, definitely. Learned a little bit, a lot. A little bit to a lot. There you go. Love that. Basically, let's see what ends up happening next. Are we going to probably be moving on? I guess maybe we'll never know because the Codecademy is taking forever to load. Yeah, it looks like we're moving on from the bash. Yeah, bash scripting is completely done. We're actually going to be going back into GitHub and Git in the next episode. So, or video, I should say. I always say episode. I don't mean it. I always mean video. If you did enjoy this video, please be sure to give it a like, subscribe, and I will see you in the next one. Peace out.